First of all, it is the most potent free radical scavenger. And here's some data looking at some other compounds as it relates to singlet oxygen, which is one specific free radical. So it's 110 times more than vitamin E, but some of these other antioxidants you'd be familiar with, green tea catechins, 560 times, 800 times more than CoQ10, which is really pertinent to this particular group for heart function, right? And if you go back down to vitamin C, it's 6,000 times more potent than vitamin C. It's very potent. Next slide. Okay, I want to review a little bit and explain what a free radical is. Most of the biomedical researchers, clinicians, healthcare providers really struggle with understanding the difference between an oxidant and a free radical. And I'm going to spend a little time explaining that because it is revealing as to why astaxanthin is so unique, so powerful, and so important. So one of the areas that I was researching in, as I mentioned, nitric oxide, I just want to point out some of the subtleties of different nitrogen oxides and what's a radical and what's not. This is just a tool. So explaining it here, these are not free radicals. Nitrous oxide, N2O, anesthetic, right? Nitronium cation, which is a nitrating substance, it's the thing that forms nitrosamines, which are carcinogens. Not nice. We don't want that, right? It's NOO plus. Nitrite. Again, one nitrogen, two oxygens, but that's negatively charged. That one's positively charged. And nitrite, as you know from being a way of preserving meat like bacon. No big deal. Nitric oxide is a free radical. And nitrogen dioxide is another free radical, so that's one N, two oxygens. Very similar over here. This one's smog. It's the brown gas in smog. Again, this forms carcinogens, and this forms bacon. Very, very different actions. And nitric oxide, of course, is a vasodilator, neurotransmitter. The difference between what's a free radical and what is some other reactive species is that a free radical has an unpaired electron in its outer orbit. Nothing to do with charge. It's just spinning around unpaired. Why is that important? Because electrons love to spin in their orbits in pairs. The way I like to talk about it is dancing partners. Excellent. So a free radical wants a dancing partner. Who here likes to go dancing by themselves? Right. If it was me, it would be particularly ugly. It would be probably a YouTube moment, but not very good. You need a dancing partner, right? So a free radical is either going to donate itself to another free electron to form a dancing partner or steal one. That's the nature of its reactivity. All it wants to do is orbit in a pair. And a very, very good free radical scavenger by explanation is the chemical that finds a dancing partner for that unpaired electron. And I'd like to consider that astaxanthin is actually the Tinder of free radical chemistry. For those of you who are familiar with social apps and singles, finding a dancing partner is important, and it's really the dating app of free radical chemistry. A lot of other so-called antioxidants are not really good dating apps. And the reason being is they may pair up that electron, but they stole the dancing partner from another situation where they were either married or in a significant relationship, and took the electron, made the dancing partner over here, but on this side, there's a very angry spouse. And that's why when you hear that sometimes antioxidants act as pro-oxidants, it's they did make the dancing partner, they paired it up here, but they've left the angry spouse. And you end up having as much damage, even more, than what you started with. So that's the sort of metaphors that I'd like to do. Let me give you some explanations of how it all works. Next one. So astaxanthin is a pure antioxidant. It has no appreciable pro-oxidant rate, but these other carotenoids do have both antioxidant and pro-oxidant characteristics. That means it will pair up that unpaired electron by stealing from a previous pair and making an angry spouse. Next slide. So what does all this mean as it relates to cell function? This is actually a study that's in human fibroblasts. It's a cell culture study, so here's the control. It's hit with singlet oxygen, a free radical, and you get this degree of cell death, right? These are all other so-called, antioxidants, what you would consider nice, friendly, effective free radical scavengers. And you'll note catechin, vitamin C, alpha-lipoic acid, the level of cell death is actually exacerbated over just singlet oxygen by itself. It's not helped the situation, it's made it worse. And it's the reason for it having a pro-oxidant activity. Tocopherol is not bad, CoQ10 is about normal, and astaxanthin is completely effective in blocking the cytotoxicity of singlet oxygen. It's a pure free radical scavenger and antioxidant. Next slide. So just taking that concept and moving it a little bit further, when you have oxidative stress, one of the things is that you change this tone within inside a cell that leads to an alteration in gene expression. There are a number of transcription factors which alter, they're like switches on genes. They either turn them off or on, specific genes. And that tone, that basic activity of oxidants inside cells determines which switches are on and which switches are off. And inflammation is particularly important in this particular area. NF-kappa B is the master switch for chronic inflammation, right? And NRF2 is often called the longevity switch. If you activate NRF2, you live longer, cells live longer. And heme oxygenase is just another downstream effect from NRF2. So this relative balance of oxidative stress affecting these switches, NF-kappa B or NRF2, determines what happens to a cell and what happens to inflammation, whether it maintains in a chronic mode or switches off. So oxidative stress is the driver and astaxanthin is the modulator, right? Moving it a little bit further, when you have oxidative stress, one of the things is that you change this tone within inside a cell that leads to an alteration in gene expression. There are a number of transcription factors which alter, they're like switches on genes. They either turn them off or on, specific genes. And that tone, that basic activity of oxidants inside cells determines which switches are on and which switches are off. And inflammation is particularly important in this particular area. NF-kappa B is the master switch for chronic inflammation, right? And NRF2 is often called the longevity switch. If you activate NRF2, you live longer, cells live longer. And heme oxygenase is just another downstream effect from NRF2. So this relative balance of oxidative stress affecting these switches, NF-kappa B or NRF2, determines what happens to a cell and what happens to inflammation, whether it maintains in a chronic mode or switches off. So oxidative stress is the driver and astaxanthin is the modulator, right? Next slide. How do we know this? In terms of the studies, this is what happens in cell chemistry. So this is a particular type of cell. This is a neural cell. And what happens is NF-kappa B is normally anchored in the cytoplasm. It's got a physical attachment, and it keeps it away from the DNA, so it can't switch on the genes. And when you hit it with an agonist, in this case lipopolysaccharide, it moves over and binds to the DNA, and you get this sort of reflection in the colors. When you have LPS, bacterial endotoxin, and astaxanthin, you can see that none of the NF-kappa B has moved over into the nucleus. It's not binding to the genes. It's not forming an epigenomic action, and the genes aren't turned on. So astaxanthin will negate chronic inflammation. And on the right, you can just see that these are reductions in interleukin-6 in two sources of glial cells relating to neurovascular inflammation. Okay, next slide. So moving on, understanding that oxidative stress is a source of chronic inflammation and astaxanthin is a preeminent free radical scavenger and negates the switches that regulate the chronicity of inflammation. How do we apply it, and how can we use it? So it's working early on in terms of free radicals. We'll get to mitochondria in a second. It affects the switches and determines what's the degree of inflammation that's driving reductions in the quality of life. Astaxanthin will negate the accelerated aging that's associated with chronic inflammation and oxidative stress. So next slide. In addition, this sort of is a summary